Welcome to the speakers. I will give you a few minutes to introduce yourself, a few seconds actually. This is Alan May. I will be the moderator of this session, which will be structured as follows and as usual. After the presentation of myself and the speakers, we will have 45 minutes of presentation, then 10 minutes of Q&A, and then a few more minutes for final Q&A and summary. So this is Alan May. I am a volunteer on this OWASP conference. I am working at Synopsys, where I develop sales with leading system integrators, and I'm based in France for the time being. Thanks a lot. Gabor and David, if you want to introduce yourself.
Yes, my name is Gabor, and just in a few words, I am one of the co-founders of a security company called OWASP, and this is where we are from. We are based in Hungary mainly, and in the US. So I have also security backgrounds, and mainly in malware security and virtualization, and I played a lot of CTFs back in time. So this is my short bio. David, the mic is yours.
Yeah, thank you. My name is David. I am currently working at OWASP as a full stack engineer, and besides that, I also do bug bounties, and I work around the web security field for a few years. Now. Currently, I'm in San Francisco, and it's in the morning, and Gabor is back in Budapest. And for him, it's the afternoon. Yeah, thank you. That's it for my introduction.
You can start immediately. Huh?
Okay. Do you see my shared screen?
Yes. Actually, yeah, the audience can put questions here in the Whova Q&A, and we'll take them at the end.
Okay.
So, since you are two speakers, right, it will be interactive, correct?
So we will be switching around one time in the middle, essentially.
Okay. Yeah. Go ahead.
Yeah. So, all right. So, thanks for joining. We are going to talk a little bit about trusted types, and trusted types is trying to handle a really interesting issue, which is called DOM-based cross-site scripting. So what is cross-site scripting? So cross-site scripting is everybody thinks when an alert window pops up as a result of an injected script is a cross-site scripting. But as the name suggests, cross-site scripting is something which crosses the borders of different sites. And this is reached by injecting a script, for example, into the application, into the web application. And according to different bug bounties, it is reported to be one of the most popular threat vectors today. So this report is from HackerOne from 2020, and bug bounty platforms just publish different websites which promote the opportunity to be hacked by different hackers. And according to this report, cross-site scripting comprises 23% of all the reports found in 2020. This is quite a large amount. So it means that the problem still exists, and this is something which we should take into account. At the same time, if you remember, in 2018, Maria Henrich had a very interesting talk on cross-site scripting. What he said is cross-site scripting is dead, we just don't get it. So what he meant is that we already have the tools, we already have all the knowledge to stop cross-site scripting. He mentioned, for example, content sanitization, content transformation, or content restriction as a methodology to stop cross-site scripting as a whole. But at the same time, he highlighted that there are some edge cases where cross-site scripting still exists, and one of them was DOM-based cross-site scripting. So why is it a problem? As you know, today we tend to use single-page applications, SPAs, which means that the server-rendered option to generate a new website is getting a bit deprecated, and we try to solve everything on the client side. So we try to push the logic to the client side. It means that the number of JavaScript code will grow day by day. And of course, if the JavaScript code itself grows, then it's going to give a really, really fertile ground for DOM-based XSS. So how does it look like? Really simple DOM XSS is like this. So you have an HTML file. In the HTML file, you have a left value and you have a right value. In our case, the document body.inner.html is the left value, which is called a DOM sync. A DOM sync means that something which consumes an input from a user or from an assignment. And in this case, what you see here is that we assign to this body.inner.html the window location hash. And of course, we embrace it into a header. So what we do here is that we simply merge two channels, a data channel and a control channel. The control channel is something which is controlled by the attacker or user, which is location.hash, and the data channel is the left value, so inner HTML. So what we try to do now is by merging these two channels, and as a result, we give the control to the attacker. So if we have a website like this with a DOM sync like this, then what we are going to have is a simple cross-site scripting, which is, in that case, an alert window is popped up. So as you see, the problem is with us. And why is it a problem? Because as you saw, it's really easy to create such a thing. The DOM API was designed without a security mindset. So there was no real security engineering when the DOM API, the document object model API, was designed. So it means that there are many, many ways to give a value to a DOM sync. There are over 60 DOM syncs all around in the DOM API. So we just enumerate a couple of them here. So you can use evil, or you can use the script to be assigned by the script that can be assigned, or the div that can be assigned, or the a element can be assigned. So basically, there are various ways to assign a value to a DOM element. So it means that it's really, really difficult to track where a given value comes from. So you can imagine that a value might land at a given specific DOM sync from really various resources. So Google had a really, really interesting research back in then, and they created a tool called Safe Types. And Safe Types was a solution where they wanted to somehow handle DOM-based cross-site scripting. And from these Safe Types, after 6 years of research and realizing that this is something which works, the Google team decided to release it to the public and kind of tries to now standardize it as a trusted type. So trusted types comes from Google originally, and they are the driving force behind this research project. So the main idea behind trusted type is the following. So the DOM API supports not only the string-based assignment, but you can also assign objects to a left value. So on the left lane, you see that there is an application JavaScript which tries to assign a pure string, a plain text string, to a DOM sync, to a DOM element. And what trusted type does, that it restricts that only typed objects, trusted types objects, can be assigned to a value. So if something is not flagged, not tainted as a trusted input, then the browser will not do this operation. So it will not do the assignment. It will drop an error. There are different configurations, but ideally it drops and it won't run the assignment. So on the right lane, you see how it works. So basically, in the first place, you have the input, which is the very same string. And first, you would like to somehow transform it to a trusted HTML. So to transform it, you have the trusted types policy. And the trusted types policy is something that you as a user can define. There are also some restrictions that who is the one who can define such a policy, but ideally you have restricted, whitelisted policy that these are the policies that can be used only by the application itself. So once this policy retrieves this string, it's going to transform it to a trusted HTML. And this trusted HTML will be then later passed to the DOM sync. So from now on, we can create a rule that all the DOM syncs, all the over 60 DOM syncs can only accept trusted HTMLs or trusted URLs or trusted scripts, which I'm going to mention later on. So type-based protection is introduced by this idea. So as I said earlier, it is enforced by the browser itself. So there's no way to cheat it. So there is no way to say that, hey, I wouldn't like to have this and this part of the code be regulated by TypeScript, by trusted types, but this is an overall protection. So even if you are about to introduce a third-party library, it's going to affect this as well. That's why it's a great idea. And how you can use it in practice, it's quite simple. So just back to the previous example when we used body.innerHTML. So we now assign a simple pure string hacked to this body inner HTML. And you see when this trusted type is turned on, the browser will report an error that this document requires a trusted HTML assignment. So it enforces that only a trusted HTML object can be assigned to OWASP. And also it drops an error, type error, failed to set the inner HTML property on, and this document requires trusted HTML assignment. So it's quite clear. So how do you turn it on? So to turn it on, you need to use content security policy. And in a content security policy is something which is returned by the server, and the browser will parse it and understands what kind of options, what kind of restrictions are turned on. So here we define that we would like to use a policy. In our case, this is called my policy. This is the policy which we are going to use and where our regulation, where our restrictions will be inserted into. And the required trusted types for script means that any type of script will go under the restriction mechanism, the sanitization mechanism of trusted types. So why is it good? Because you can use any type of sanitizer from now on, for example, DOM Purify, or any kind of HTML purifier, whatever sanitizer you would like to use inside the policy. So creating a policy is also really easy because it's in an extra abstraction layer atop just a simple sanitization mechanism. So you create a policy, which in our case is called my policy, and basically it takes a string as an input by the create HTML function, and it returns a saved version. Of course, there is no sanitization in this very simple example, but you can write any type of safety logic here. So it's quite simple. So as I said earlier, there are, by definition, by the standard, there are 3 different types of elements that you can define a trusted type for. So you can define a trusted type for scripts URL. So this is something where a script, for example, Google Analytics will be embedded somewhere into your site. So you'd like to make sure that this very script, the URL, which refers to a script, is safe and sound. You can refer to a script, which is any kind of script which is assigned to a DOM sync, or HTML or an HTML tag is assigned to a DOM sync. And there is also a fourth option mentioned by Google, which is the URL itself, but this is not part of the standardization as we realize it. So just wrapping up, what I was talking about is just, first and foremost, you must approve all values before getting inserted into the DOM. So no matter where the data comes from, everything needs to be accepted by the trusted types policy. And this is a really, really great win. So nothing can accidentally end up in the DOM. So there is no way to circumvent somehow and say that, oh, I'm an exception. There is no such a thing. And here is an also really important takeaway that if there is a bug in the policy, then you might pass trusted types. Otherwise, it's impossible. So if your sanitization procedure is working properly inside the policy, that there is no bug that can pass this kind of mechanism. So another key thing is that there is a centralized location for security operations. So once you decide to review the website to find DOM XSS, you need to only parse the policies. So if you write these policies properly, the security review has to cover only these policies. And these are the most important things. So basically, process scripting, DOM-based process scripting is reported to be totally circumvented by trusted types, reported by Google. And I think this is the time when I give the mic to my colleague, David, and he's going to tell you why. So thank you.
Thank you, Gabor. I'm going to go ahead and share my screen just so I can control the slides. Okay. Sorry, I might be having a little bit of technical difficulties. Let me just.
This is Alan, the moderator. No questions so far, but do not hesitate to leave questions or comments on the Whova Q&A. Back to you, David. Thank you.
Thank you. Thank you so much. So my screen share, let me just rejoin just a second. Okay, here I am. Can you guys hear me?
Yes, we hear you.
Thank you. It says your screen sharing is paused.
Yeah, it says it started, but
okay. Oh, okay. Now you can see the slides, right?
Here we go. Trusted types.
Okay, thank you. Thank you. Awesome. Sorry about that. All right. So what my part in this presentation is going to be about how we experienced this at OWASP, because we planned this sort of experiment of trusted types sounded great in theory, but we wanted to try it out. How does it look like to actually implement it into a sort of mid-sized application? And I'm going to tell you all of the challenges that I was personally doing this research and this implementation, and I'm going to tell you what challenges I have faced and what kind of experience it was to convert a website that doesn't support trusted types into supporting trusted types. So I think the first and most important part to mention is that our platform our website is running on Angular, and Angular handles most of the stuff that we do. This means that the core stuff should be solved by Angular itself, and indeed it is. So if you go to the Angular documentation, there is a section about enforcing trusted types, and it clearly says that it should be quite easy and straightforward. The documentation is very slow, very small, and it mentions that there are 3 specific policies that if you enable, as Gabor showed before, these policies are handled by Angular. You don't have to do anything with them. You just have to enable them in the content security policy header that we looked at. And based on Angular's documentation, if all these policies, then everything will just work. And Angular will use these policies to actually render the page and to inject the HTML into the DOM. Now, with this, of course, you're putting the trust into Angular's hands, but that's sort of what you do when you are using a framework like this one. So I thought that this is very easy. I just enable all of these policies. I actually didn't even need the unsafe JIT thing because we are not using the JIT compiler stuff. So I enabled Angular and Angular unsafe bypass, and it sort of worked. It wasn't that easy. The first challenge that happened was that we are using, well, Webpack under the hood, or Angular sort of uses it under the hood. And it has a feature called lazy loading, which means that it loads modules only when they are necessary. Like that sort of means that there are specific JavaScript files in the final of the site. And when you navigate to a specific feature of the application, it will load that given JavaScript file. Now, this sort of dynamic loading of JavaScript files wasn't really compatible with trusted types at the Webpack version that we were using. So I started looking around, and I found a GitHub issue. There will be a bunch of screenshots of GitHub issues because people are still figuring this out. I found a GitHub issue which reported exactly this: that you enable you go over the official Angular docs and you enable the policies, and it's not going to work because lazy loading is not supported properly. And the response of the Angular team to this, or like the GitHub issue response, was simply that they opened up a pull request to remove the documentation about trusted types from the Angular docs. So they stated that, okay, so we are actually not supporting trusted types, just remove the documentation from the Angular docs. Well, that was sort of an unexpected, I wasn't looking for that. I was looking for a solution and not removing it from the docs. So I had to look a little bit deeper. And there were two ways to kind of work on this first Webpack lazy loading issue. The first was that, first of all, we were using Webpack 4 point something, and Webpack 5 is actually supporting trusted types when you load these dynamic modules, and we needed that. Now, to get Webpack 5, you have to do it. You either we had Angular 11, I have to say that first, because Angular 11 is sort of an older version of Angular already, so there are newer versions already. But we were running on Angular 11, and that had the Webpack 4 version connected to it. Now, there is something called the experimental Webpack 5 support in Angular 11, which is not really supported for production, but you can essentially use Webpack 5 with Angular 11. If you specify, if you pull in a few like third-party config packages and configure it and manually bump the dependency. So that was one way to do it. And the other way to do it was to upgrade the whole application to Angular 12, because Angular 12 was actually using the newer Webpack version. It was actually using support. It was including support for the whole Webpack part of trusted types. Now, in this thought process, I was weighing all of these options, and we decided to, based on the fact that Angular 11 is already deprecated, and it already should be upgraded anyways, we decided that the way to go is to upgrade to Angular 12, because that's already a supported version of Angular, and that sort of worked. Now, a Angular update to an application is quite a big deal, I would say. So you wouldn't expect to do it every single day, but it went smoothly enough. I guess if you have an Angular application, you experience this a few times because you have to keep on upgrading. There is a very helpful guide at update.angular.io, which tells you a little checklist. You provide what version from and what version to you are upgrading, and it tells you to what specific code, what sort of usages you should check in your code, which might break in regard to this upgrade, and what you should do to upgrade. I went through all of this, all of the checklist, and I looked at everything, and everything looked smooth. So I upgraded to Angular 12. Now we had up and running on Angular 12, and once again, the documentation here was straight up terrible. So even though Webpack 5 was now used and Angular 12 was now used, which had support for trusted types, you still had to enable a new policy, which was used by Webpack. So Webpack has a policy, just as I showed you earlier, that Angular had 3. Now Webpack also had 1 in this new configuration, and you had to enable that. Now, but it wasn't obvious what's the name of that one, but in the GitHub, Angular's GitHub code, or Angular source code, you can sort of find it out or by the crash logs that it's called Angular #builders. So if you enable this policy with the other three that I showed you earlier and upgrade it to Angular 12 at least, then you were sort of good to go in terms of Angular. So after doing that and enabling those 3 or 4 policies in the CSP header, our core application logic was working well and trusted types were enforced. But it's not where the story ends, because you rarely only use native or like pure Angular. You already you sort of have other stuff too sometimes. Yes, this is the 3 policies that I talked about. I'm sorry about that. The Angular unsafe bypass, and the Angular bundler. Enabling these 3 enabled the Avatar web application to function quite normally, except a few exceptions. And the exceptions are gets so tricky. So I went on and started, using testing the application to figure out, okay, it sort of works, but what is still broken? And I found a few things, and these were mainly 3 specific issues. The first issue was with, as you already noticed, these are with third-party packages that we are using. That's the theme, really, and our own analytics implementation. So first issue was what's very obvious is that we have these challenge and exercise pages on the platform where our users can start up exercises. And these exercise pages have descriptions, and these descriptions are written using Markdown. And when we are displaying these descriptions on the web application, we are using a package ngx markdown to parse the markdown and display it in some type of HTML. And this package was, of course, not supporting trusted types because it's still in a very early phases. So as you can clearly see, it was crashing when it tried to put the parsed HTML description into the DOM. I will go into more detail in a bit. On the right side, there is another area which was a bit painful to fix. This was with a feature that we have. When you complete a specific set of exercises, you get a certificate. Now, there is a little button here which says download certificate. And what this feature, it pops up a new pop-up window, and in this new pop-up window, it puts the contents of the HTML contents of the certificate, and it issues a window.print function, and in window.print call, which triggers the browser's printing view of the certificate. So essentially, you click download certificate, and you get a pop-up which pops up a printing UI of the browser. That way, you can save your certificate as a PDF or print it using using whatever you use to print. And that was also problematic. You can see why, because it's directly interacting with the DOM as the Nginx Markdown as well. And the third issue was our own analytics implementation, which we'll get into a bit. That was also interacting directly with the DOM, and that's why it was problematic. So with Nginx Markdown, as I said before, as you can see on the left, there should be descriptions there, like text and differently formatted text on the left side, but nothing is there. And in the console, it's visible that it is crashing because it says that this document requires trusted HTML assignment, and it's trying to, the little package, Markdown package is trying to assign a string directly into the DOM. It parses the Markdown, generates an HTML, and tries to put it in the DOM, but it doesn't work because you have to put trusted HTML in the DOM. And to solve this issue with the package, I used what's called a default policy. This is in the specification. You shouldn't really use this in production, but for these sort of situations, it can be very helpful. So what a default policy in terms of types do is that it catches everything that is not explicitly sent to a given policy. So as Gabor mentioned earlier, you can create a policy, you can specify some sort of parsing logic in it, and then later on you can generate a trusted HTML using that policy by calling out that policy create HTML function, for example. But if you name your policy default and enable the default policy, the policy will catch everything that is trying to directly end up into DOM as a string is going to go to your default policy, and your default policy will have the final chance to do something with it and generate the HTML. So the browser will not crash immediately; it will give it to your default policy, and then that can handle the issue. So I plan to use this with NGX Markdown. So NGX Markdown could still, behave as usual, try to assign a string, but when it tries to assign a string, it will go to my policy. I will perform some sort of HTML sanitization in my default policy. So to create a default policy in Angular, I first had to install the trusted types package. This was necessary for to actually interact with the trusted types API, because if you don't install this, then window.trusted types is going to crash, and it's going to cause issues when you try to compile the TypeScript, because the TypeScript will not know about the trusted types syntax. So you install this one. I used to, because there is no real way to do it yet, I figured I could create a new service in Angular for trusted types. So I created a new trusted types service, and in that service, I set up a new default policy. This is how I did it. Essentially, the service created a new policy called default, and the default policy had, you can even see my little laser pointer, I hope, had this create HTML function, which just simply passed the HTML that it received into the Angular DOM sanitizer and sanitized it as an HTML. And this is what Angular is also using under the hood to sanitize the untrusted HTML. So this way, any data that was directly assigned into the DOM as a string will go through this default policy and will get sanitized by Angular's sanitizer. So hopefully nothing malicious or like unintended can end up in the DOM this way, because we have control over this logic. Of course, the real solution would be trusted types supported NGX Markdown, so that it would have its own policy, for example, and we could just enable the NGX Markdown policy in our CSV header, so we don't have to hack around with this default policy to intercept the NGX Markdown's issues, essentially. But this works for now. A little bit of a hack, but it works. So we have NGX Markdown fixed and ready to go with the default policy. Now, NGX print was a bit of a tough one. I spent quite a bit of time with that one, and it was a bit annoying. So this is how it worked. You have this certificate page. You have the little download certificate button. You click the download certificate, a blank window pops up, and it only contains the certificate contents, and then you immediately get the print pop-up on that window. It's using this package called NGX print. It's a plug and play Angular directive to print your stuff as per its description. What it's doing in very simple terms, it pops up a new window, and then it grabs some sort of HTML from your main page and whatever you specify, and then puts it into the new window and calls print on the new window. As you can clearly see, there is a lot of string operations, there's a lot of string operations happening here, and it's not at all trusted types compliant. There is no support for trusted types, this third-party library. So we had to do something. I had to do something myself. This is what it did. It first opened a new window with window.open. Then it took the certificates HTML and it said document.write the certificates HTML into the new empty window. And it tried window.printing the new empty window. Because CSP rules are inherited from the parent page to the child page, the new pop-up window still had trusted types, the same trusted types rules as the parent window. Therefore, you couldn't just put a string in there. And unfortunately, the default hack didn't work here, because the default policy only works if you have the policy registered on the page. And when you open up a new window, it will have all of the CSP rules, so it will require trusted types, but it will not have the default policy. The default policy is registered in the other page. If if you default policy, you have to register it in the pop-up as well, but there is not really an easy way to do it because pop-up is completely empty. There is nothing, it's an about blank pop-up. So I thought that the only way to fix this is to using document.write on the new pop-up. We must send a trusted HTML object because we can't do the default policy hacking here. I spent around 2 days re-implementing the whole ngx print feature and creating something that behaves exactly the same way, but rather than using strings, it sends it to my custom policy. But I faced multiple difficulties, and the whole thing just felt very hacky and very unprofessional, and not something you would really want to you really want to trust. And because of this, I ended up using a clearer, what I find as a cleaner solution. So instead of messing around with the DOM, with the HTML by manually grabbing it from the other page and putting it in the print page, I decided that I will create a new Angular view, and in this new Angular view, what it will do is that it will only display the contents of the certificate. So it will have a path of learning path certificates, the ID of the certificate /print. And when you open this Angular view, it will not do any magic string handling. It will only Angular open this page and only render the certificate. So it required me to create a new Angular view, which is once again quite a bit of work, unexpected work, if you will, because you would only think we can just turn on trusted types, but it's not really that easy. So this required a bunch of development just to fix this one specific dependency. And then later on, with the download certificate button, I opened up a new pop-up, which was not a blank pop-up, was actually a pop-up to this URL. And when this URL loaded up, this actual Angular component issued a window that print on itself, which was a bit hacky in and of itself, but it worked. And it was trusted types compliant because now Angular was doing the rendering just as in the case of the application. And Angular is working fine. We already enabled all of the policies that it requires. So the takeaway of this issue specifically is that a custom DOM manipulation logic could be hard, or it could be even impossible to implement with trusted types. And I think you can clearly see a theme here with these two examples, with the ngx markdown, with the ngx print. It's sort of obvious that when you use third-party libraries, you go off the main road of just using pure Angular. You will have to deal with this stuff if you plan on using trusted types, unfortunately, because every library in an ideal world would support trusted types, but they don't in the real world. So you either hack around it, you either modify the code of the library, or you re-implement the library and stop using third-party library itself, which are a bunch of development-heavy considerations, especially if you have hundreds of third-party dependencies that you rely on. But thankfully, we only had 2 of these specific cases, so we were lucky enough in this regard, but we still had our analytics implementation left. Now, our analytics implementation was necessary for this cookie accept or cookie pop-up that we had on the website. So without going into too much details, what happened on there is a very extensive and a complex system that we have implemented in the code base, which handles these analytics providers on the application. So a developer can register an analytics provider, for example, Google Analytics. And when the user accepts the cookies, Google Analytics and all of the other providers will get injected into the DOM. If they don't accept the pop-up, then it will not get injected. So it will get injected in runtime. And the provider could inject a script URL or an actual JavaScript snippet. It was implemented that way, so you say that, okay, when the user clicks accept, please pull in googletagmanager.com/Google Analytics.js, or you could give it a full-blown JavaScript blob, and you could say that when the user clicks accept, just push this JavaScript blob into the page and execute it, because these analytics will work this way or that way. This is hard if you start to think of how this could work with trusted types, because clearly there is a string assignment into the DOM going on. This caused issues, and it was causing issues. So it was straight up not working when trusted types was enforced. So I faced once again a challenge, and this challenge was something that I faced multiple times on this research. Is that I wanted to stick with the trusted types principles, and I wanted to actually keep the policies secure, because the policies are the pieces of code that contain the security sensitive logic. So, as Gabor said, these are the core security logic in your application in terms of DOM XSS, if you enable it. And that's very, very nice, but it might be hard in some cases. So multiple times it was very charming to just create a policy that allows everything and call it internal avatar policy do not use and that policy would allow everything. And for example, in my can use and it would just complicate things much more developers. So but to stick with the trusted types principles, you shouldn't create a policy that allows everything. That's so at every policy station before approving the given input. So this is what I came up with. As you can see, this is clearly where this is what I mean when I say it's harder to actually say. Because it's not using HTML here, but script URLs, you can, I wouldn't go into too much detail, but essentially it depends. If you're working with HTML, you have to use this function, you have to use this for the trusted type policy. And we are working with script URLs here, and I simply parse the URL in the browser, and I checked if the origin and if the path is equal to gtag.js. In case, then I approved this. If I did not approve, and I return back an empty string. So only this specific script could be loaded. And once again, this is where the security logic is, and you have to be very careful with the way you parse URLs and you do all of that sort of validation. But that's beyond the scope of this specific talk. And in the code, I just simply went ahead and actually just instead of putting the URL into the tag.src attribute or into the inter.html, I used the trusted type service analytics policy and created the script URL and put it in the src. So the trusted script URL at this point and not string. So this way it worked because I was using trusted types. And I talked with the other team members, and we decided to skip the validation of actual JavaScript snippets, because you could sort of do that, but that would be way harder to decide whether a block of JavaScript snippet is secure or not. So we decided that this analytics policy will only do URLs. And the last and final issue, use this analytics policy that I have made, that I just showed you. And then I got this error in VS Code saying trusted script URL is not assignable to type string. And I was surprised by this error message because this is a DOM element, for example, in a tag or a script tag on SRC attribute. That's the whole point of trusted types. But TypeScript was throwing an error because TypeScript wanted me to assign a script or wanted me to assign a string as the SRC attribute. Now, that was very surprising to me because I already installed the trusted types type package. So I figured that this would take care of all of the TypeScript issues that I might face, but I was wrong. And I was very wrong. And there is an open issue on GitHub on Microsoft TypeScript repository, and it says not support for trusted API. And this is where I start to feel that this is very ready at this point. So TypeScript has a sort of syntax of what the DOM API could accept, and TypeScript thinks that the DOM API only accepts strings. So the TypeScript will code itself extended to add support for trust. Until that, you can't actually reuse it. And other people were complaining as well. For example, this person was saying that we are prototyping the use of trusted HTML at GitHub, and we would really love to see this land. And it's 20 days ago, so this is very fresh. So we are blocked by the TypeScript DOM support, and at this point, I felt like this might not make it into production. We already did a bunch of hacking, and I didn't want to hack it even more. Yes, there was a way to hack around this. I just put a TS no check into the analytics provider's first line, and this caused type checking for the whole analytics provider code file, which is a terrible thing, and you shouldn't do it. But it allowed me to get past this specific issue and ignore the TypeScript error. And yeah, it's all working now, and I only have a few minutes left. I'm just going to wrap this up real quick. So it's all working now, right? We hacked everything, and trusted types is now enforced in Google Chrome, and that's a problem. Only Chromium supports this specific trusted types implementation natively by default. And if you want to support non-Chromium browsers, then you will have to use something called a polyfill, which is a snippet of JavaScript that you put into your page. It will add support for trusted types to browsers like Safari and Firefox. And this was the last step. I had to put this into the page. And they provide a nice URL. They host and they say that you can just put the script tag into your web page, and it will add the trusted type support for non-ordered browsers. And I tried it, and that web page was giving a 404. So even the official the trusted types documentations links were broken for some reason. And that was also, once again, a not really comforting experience. I was able to get around this by downloading the polyfill code from GitHub and locally loading into the web application by saving it to the assets folder and downloading it later on in the Angular page. And this way I was able to get it working. But once again, the whole process felt very hacky, and the fact that the whole polyfill was not really working by the way they described really didn't make me feel secure about this. So anyways, this was all working now. We fixed all of the issues, and other browsers were working as expected. Even Safari and even Firefox was enforcing its trusted types via the polyfill. But as I mentioned, due to all of these difficulties and all of these hacky solutions, decided to keep it as a proof of concept and not actually release it into production. And this research and this implementation, just to give you some actual numbers and a little data for your own applications, took around like 8 days of like part-time effort, which consists of around 32 hours of work from my side. And that's not a that's a big, that might be a big development cost for you. And it feels like to me that we are still in the very early ages of trusted types, so you might face way more issues than what I did face. And that's really it for my implementation story. And I think I finished just in time. If you have any questions, thank you.
Yeah, thank you, David, and thank you, Gabor. I have looked. I have not seen any question. Can you check on your side? Maybe they came in at the last moment.
No, we cannot see. I cannot see it.
No. Yeah, and
Right now.
okay, hold on. Let me go back to screen.
Was my connection understandable? I see some.
Yes, it was.
Okay.
In fact, we have well, precisely 8 more minutes left. I had to quickly step out. If you would summarize, your 4 hands, 2-man presentation, whatever the top 3 or the top 5 key messages that you want to leave with us and with the audience.
Yes, Gabor,
Yeah.
if you want to summarize yours.
Yeah, just I dropped in a few, and maybe you can
Yeah, go ahead.
extend it. So one of the first thing is that cross-site scripting is still an active problem, and we have a lot of tools to solve it, but at the same time you have to use these tools. So we have tools, and we have to use these tools properly. This is the number one. The second thing is that trusted types is a really, really promising solution to handle DOM-based cross-site scripting totally. So the idea, if you write a proper policy, or you have proper policies for different use cases, this will handle DOM-based cross-site scripting for sure. This is the second takeaway. The third takeaway, DOM-based cross-site scripting is only a part of the whole cross-site scripting family. So you have to take into account other solutions. So if you use server-side templating, DOM-based trusted type is not your solution. So be careful what kind of protection guardrails you implement, because, for example, a nonce-based CSP would be much better for server-side templating. So this is the third thing, that to find where trusted types fits into your implementation process. So this is from me, and David, I give you also some credits.
Thank you. Yes, what I feel like is that, as you said, yes, this is a very promising and very nice way of looking at DOM access defense. So I really support this new specification, which is still very much in an early phase. And this is what I wanted to highlight, is that as you've seen in my story, the key takeaway is that it was still very in the early phases. It was still very, GitHub and Microsoft are still blocking this. They are still working on implementing this in a major projects such as TypeScript. So it would take time to have everything running very smoothly. And until then, unfortunately, we have to really think of trusted types as a little experimental new technology, and try pushing all of the tools and vendors that we are using, and try making them implement this. So we could use trusted types as it is intended to be used, which is a very, very powerful and very, very nice tool against DOM-based XSS.
Okay. And maybe to conclude, any best practice besides what you have given us different solutions, right? I think, David, you showed us 5 solutions. Is there, based on your practice, or Gabor's, one that you favor?
What I would say is that is that I mean, implementation. Looking at the implementation, what I would say is that it really depends on how many custom stuff you are doing in your application. So ideally, if you want to build a new application from the ground up, you can easily make it trusted types compatible. You can just have to think of using trusted types from the start. If you have a legacy application, you should really, the biggest challenge is to think of how you can convert it into trusted types compliant and what you can do with all of the third-party dependencies. It's really up for your development or your priorities to decide whether or not you want to do that.
Okay. Looking at the time, we have 3 minutes left, so I think it's time to say thank you for your presentation. Thank you for the hard work of coordinating a two-speaker presentation, which was, I think, quite lively. Thanks a lot again. For the benefit of the audience, you have the choice between 5 sessions that are running concurrently. Yeah. The next session will start here in 3 minutes. It will be titled Shift Left Security with Security Test Pyramid, and the speaker will be Andreas Volk out of Germany. Thank you, David, again. Thank you, Gabor. You can now disconnect, and I will stay here to welcome your successor. Bye-bye.
Thank you.
All right, thank you, guys.
Bye-bye.